Now we're going to complicate things even more. Yay. We're going to look at sex-linked crosses, which are diseases that are related to one sex over the other, one gender over the other. Now, some traits, the reason why this happens, are because some are located on X or Y chromosomes and then get passed along based on your gender. If you look, the X chromosome is actually physically longer than the Y is. So there are some genes, if I could clear this up here, that are coded on one but not the other. Now this one you can see in your notes, you don't really need to see on the picture here. Let's say you have a gene located right here on the X chromosome. Well, there is no spot for that on the Y because the Y is shorter. So men, because men are XY, only get one copy of that gene, whereas a female who would be XX get two alleles or two copies, two chances to fight off that condition. So let's say we're looking at Parkinson's. You have three options: big P, big P, big P, little p, little p, little p. If you are little p, you'll have the disease. Because you have three possible letter combinations, you have extra chances not to get the disease. So there's two chances not to, here's one chance that you will. Sex-linked conditions don't work out so well. The gene for baldness is located only on the X chromosome. Because the Y is shorter, there's no locus or location for the baldness gene. That would be like up here, baldness versus no spot for it on Y. So the Y does not have the gene associated with it at all. Let's say that capital B equals not bald, whereas little b is bald. You need, for sex-linked genes, to include X and Y. A female is XX. A male is XY. A female has two chances because the chromosomes are longer, both of them are X's. She has two copies of the baldness gene. So if she has a big B, we write it this way: X big B, X big B. This needs to be a superscript. This would be a female because she's XX and not bald because capital B, not bald. This female, two X's, big B, little b alleles, heterozygous. Female, also not bald. She has the big B, therefore she's not bald. This female would be like big B, little b, female, XX, bald. She has two recessive alleles. Now males have that Y chromosome that's short. So down here, from his mom, he gets his X chromosome. XY means male. Big B, and there's no second option. This male is not bald. This male, however, gets a little b from his mom, his X chromosome. The Y chromosome doesn't have this because it's too short. So all it takes for a male to get a sex-linked disorder that's recessive is one bad copy. In this case, this is a male that is bald. So boys, if you go bald someday, it is your mother's fault because she's the one who gives you the X. With sex-linked conditions, men are more likely to have the condition. This is what I just said. They don't have that second chance like a female does. What does this look like on a Punnett square? It's going to be similar to what we did, except now we need to have this X and Y in our square, and that complicates it a little bit. So Dad, just like before, we're going to separate these two: X, little b, Y. Male, because it's XY. Bald, because he has this little b, it's recessive. Mom is not bald, but she carries it because she's heterozygous. So X big B, X little b. Multiply them out. So here's how you do it. Big letter first. X big B, X little b. X big B, Y. X little b, X little b, X little b, Y. Okay, that's where these came from, like so. These from here, those from there. The ratios, we have four possibilities. X big B, X little b, 1 out of 4. X little b, 1 out of 4. X big B, Y, X little b, Y, each of those is also 1 out of 4. Phenotypes, what are they going to look like? We have two things to include here. We have gender and baldness. So first, XX is a girl. Big B, little b. She has a big B. Big B means not bald. 1 out of 4. This girl, 2 X's, so it's a girl, little b, bald. 1 out of 4. Here, boy, XY. Big B, not bald. 1 out of 4. X, Y, boy. But he has only that one chance, and his one chance gave him a bald allele, so he's going to be bald 1 out of 4. So if these parents had a child, there's a 25% chance of a girl that does not go bald, a girl that does go bald. Another 25% chance, boy not bald, 25% chance, boy that will be bald. Let's do another. Okay, Dad, X, big B, Y. Now I made a mistake here. If this is a big B, he's not bald. Make sure you fix that. Mom, X little b, X little b. I made a mistake again. You can tell I just kind of copied and pasted. She is bald, not a carrier. Carrier would be one of each. So Mom is bald, Dad is not bald. Let's see what their kids would look like. X, big B, X, little b, X, big B, X, little b, X, little b, Y, X, little b, Y. Not so much variety this time. Ratios, we only have 2 possibilities. X, big B, X, little b, X, little b, Y. This would be 2 out of 4. This would be 2 out of 4. You could also write out the other possibilities, but I'm not going to make you do that here. Phenotypes. Our first one, XX, so that's a girl. Is she bald or not? Well, she has a big B. She's okay, not bald. How many chances are there of that? Well, this is a boy, so that automatically tells me there's a 50% chance, or 2 out of 4, that if it's a girl, she won't be bald. Here, boy, and X little b, no other shot here. It's going to be bald. 2 out of 4. So if this family had a girl, there is a 100% chance that the girl will not be bald. If they have a boy, though, there's a 100% chance that he will be bald. Okay? Here's another one. If you're feeling confident, skip ahead to the answer after you figure it out. If you're not, stick with me. Dad is, so let's go back here first. Color, dominant. Colorblind is recessive. Sex-linked. Dad is not colorblind. X big R Y. Mom is heterozygous. She has one of each. Remember, female is XX, is a carrier, big R, little r. Okay, so let's figure out. Dad, X big R Y. Mom, X big R, X little r. Multiply it out. X big R, X big R.
X big R, Y, X big R, X little r, Y. Genotypes, X big R, X big R. I only see one of those, 1 out of 4. X big R, Y, 1 out of 4. X big R, X little r, 1 out of 4. X little r, Y, 1 out of 4. Phenotypes, first female, or girl, you could do either. Female, she colorblind? No. She colorblind? No. So female not colorblind. The other option would be a female that is colorblind. We can have a male that's not colorblind, and a male that is colorblind. Let's go back and see what we have here. Female not colorblind. Denominator is the same, so we add the top, 2 out of 4. Do we have any females that will be colorblind? No. Male not colorblind. Oh, he has a capital R, he's good. This one has a little r, he's going to be colorblind.
So now we have some differences here. If they have a girl, there is no chance their girl will be colorblind. A girl will always be able to see color in this case. But if they have a boy, there's a 50-50% chance, because if we're looking at boys only, half of the boys would be colorblind, half would not. Last one. Dad is colorblind. Dad, X, Y. If he's colorblind, that's a recessive allele. Little r, he doesn't have a second chance. Mom, homozygous dominant. She's female, 2 X's. 2 of the same big letters. Big R, big R. Genotypes, phenotypes, I'm not asking it on this one. I'm just saying, what's the chance that any of their kids will have color blindness? Can see color, can see color, can see color, can see color. 0% chance that their children will have color blindness. In this case, all of their children will be able to see color. So, for the conference, I'm going to give you random options here for a sex-linked disease. You don't know what I'm going to give you, so you need to make sure you know how to do this, and I'm going to have you actually do a sex-linked cross in front of me. If you're not stuck, I'll practice with you before you actually do this for real. So if you want some practice, come see me, and then we will conference on a sex-linked cross.